When we look at Earth's topography, mountain peaks naturally draw the eye. But if you scale a sheer, dramatic rock face only to find a vast, level expanse at the summit, you are standing on a plateau. These structures are built over millions of years. Deep underground, Earth's crustal plates smash into one another, melting and forcing heavy rock back toward the surface to form these massive uplands. Elevation alone does not define them. Some sit barely above sea level, others tower over the clouds. The deciding factor is always the flatness of the top, rather than the absolute height. While jagged peaks command the skyline, these flat-topped masses dictate the path of regional weather and house a disproportionate share of the world's mineral wealth. To see how these uplands distribute wealth and water, we can trace them across the continents, starting in North America. The Colorado Plateau is a massive upland spanning Utah, Arizona, and New Mexico, where the Colorado River exposes deep groundwater reservoirs. Further north, the Columbia Plateau reveals a different origin. Sitting between the Cascade Range and the Rocky Mountains, this expanse was formed by volcanic eruptions that left behind a thick coating of basalt lava. Moving to the east coast, the rugged, dissected Appalachian and Piedmont plateaus step down from the mountains to the Atlantic. And panning north into Canada, the Laurentian Plateau forms the North American continent's ancient geologic core, rich in high-quality iron ore. Across the border, the Central Mexican Plateau occupies much of northern and central Mexico, leading down to the tin-rich Altiplano in the Andes, an intermontane plateau that houses the Bolivian capitals of La Paz and Sucre. On the eastern edge of South America, the ancient rock of the Guyana and Brazilian highlands span nearly half of Brazil's land area, protecting some of the richest biodiversity on the planet. Finally, at the southern tip of Argentina lies the Patagonian highland. Stripped of moisture by the Andes, this rain-shadowed desert forms a vast flat expanse used primarily for large-scale sheep rearing. Across the Americas, this longitudinal spread creates a gradient of physical utility, transitioning from the mineral wealth of the northern shield to the southern agricultural plains. European plateaus serve as deep-seated cultural and economic centers. In France, the Central Massif provides the ideal elevation for grape cultivation, while the Meseta Central dominates the interior of the Iberian Peninsula. Northward, the Transylvanian Plateau anchors Romania, Norway's glacier-bordered Hardangervidda, and the rolling central Russian upland define the high ground of the European north. Plunging south into the center of the Sahara Desert, the terrain shifts. The Ahagar Plateau rises nearly 3,000 feet above the sand, with its highest peaks emerging as jagged columns of rock. In the Democratic Republic of the Congo, the Katanga Plateau acts as a massive mineral vault. This elevated region is one of the world's primary sources of copper, cobalt, and uranium. On the eastern side of the continent, the rugged mass of the Ethiopian highlands connects to the East African Plateau, a landscape defined by the deep trenches of the Great Rift Valley. The African continent concludes at its southern tip with Table Mountain, a prominent, level plateau standing 1,000 meters above Cape Town. By lifting ancient crustal formations close to the surface, Africa's plateaus serve as the continent's primary economic engines, providing access to the heavy metals that power modern technology. Moving into Asia, the scale of these uplands increases. The Arabian Plateau forms a massive horizontal surface across the peninsula, while Turkey's Anatolian Plateau provides the deep channels required to catch and route the Tigris and Euphrates rivers. Continuing east, the Pothohar Plateau borders the Indus River in Pakistan. Below it, the Deccan Plateau covers most of southern India, forming the largest volcanic feature on Earth, 500,000 square kilometers of stacked basalt. Past the crystalline rock of Myanmar's Shan Plateau lies China's lowest plateau. For millennia, winds have deposited fine soil across this region, building a productive silt that feeds the Yellow River. In the north, the high, dry steppes of the Mongolian Plateau merge into the Central Siberian Plateau, a territory of wide ridges that occupies an entire third of Siberia. But the climax of the planet's topography sits in South-Central Asia. Formed by the collision as an Indo-Australian and Eurasian tectonic plates, the Tibetan Plateau is the highest and largest in the world. Covering 2.5 million square kilometers, its valley floor rests at 16,000 feet. This massive structure acts as a physical wall. When atmospheric currents hit it, they reverse Hadley cell convection cycles, driving India's monsoons southward. The height and scale of these Asian uplands force the atmospheric shifts that guarantee a consistent water supply for billions of people. To see how universal this geologic mechanism is, we can sweep down to Australia. Here, the remains of the ancient Gondwana rock shield form the Western Plateau, an arid expanse roughly the size of continental Europe. At the extreme south, the Antarctic Plateau cuts directly across the South Pole. Even under thousands of feet of ice, the bedrock forms an elevated flat plain, peaking at 3,000 meters above sea level. They even form in the deep ocean. Between the Seychelles and Mauritius Islands, the Mascarene Plateau rises from the Indian Ocean floor, entirely submerged but structurally identical to its terrestrial counterparts. When we pull back to view the Earth as a whole, the global network of plateaus reveals a distinct pattern across the planet's surface. These regions are the ancient, enduring scaffolding of the planet, forged by tectonic pressure and volcanic floods over billions of years. By lifting the Earth's crust, they force the rain that feeds the world's great rivers and hold the mineral reserves that power modern civilization. Earth's flat-topped giants are the hidden architects of the surface, shaping exactly where our civilizations settle and how the planet operates.